there may be a planet in our solar system that no human has ever seen. It may outweigh Earth 5 times over and take more than 10,000 years to circle the Sun. Yet after decades of searching, astronomers cannot point to one pixel and say, "There it is." The case for Planet 9 comes from smaller worlds. Some of their motions fit the hidden planet idea remarkably well. One new object does not. This is Cosmion. Point it at any question in the universe, and it will show you the answer, whether you can bear it or not. Tonight, we point beyond Neptune, at a world that may be hiding in our solar system. Neptune is about 4.5 billion kilometers from the Sun. Light needs more than 4 hours to cross that distance. It is the last confirmed giant planet, but perhaps not the last. Keep traveling. Past Neptune, Pluto, and the scattered ice beyond, the Sun shrinks from a disk into a fierce point. The known planets gather behind you. Ahead, the map is mostly empty. One leading model puts Planet 9 hundreds of times farther from the Sun than Earth, on a long, stretched orbit. A year that could last 10 to 20,000 Earth years. Sunlight there would still cast a shadow, but the Sun would look painfully small, and the planet would return almost none of its light to us. It would not resemble a larger Earth. Current estimates suggest a cold sub-Neptune, perhaps 5 to 10 Earth masses, beneath a deep atmosphere that has never felt a warm day. No one has measured its color, weather, or size. We have only a suspect shaped by gravity. This search has worked before. In the 19th century, astronomers saw Uranus moving unexpectedly. They calculated where another planet should be, aimed a telescope there, and found Neptune. Planet 9 is harder. Its fingerprints are not in one familiar orbit. They are scattered among faint bodies so distant that many take thousands of years to circle the Sun. Sedna is one. It never comes close enough for Neptune to explain its detached path. Other objects have similarly stretched or steeply tilted orbits. Something disturbed the outer solar system. In 2016, Konstantin Batygin and Mike Brown showed that one distant planet could shepherd these paths for billions of years. The bodies would not sit together, but their orbits would point in related directions. The same planet could produce extreme inclinations, including objects traveling almost across the plane of the known planets. One unseen mass seemed to explain several kinds of disorder. In 2024, an analysis tested long-period objects that cross Neptune's orbit while staying near the solar system's main plane. A model with Planet 9 matched them far better than one without it. That specific comparison rejected the model without Planet 9 at about 5 sigma. This supports the model. It is not a 5 sigma discovery of the planet. Gravity has given astronomers a trail. It has not given them an address. To see Planet 9, sunlight must reach it, strike its atmosphere, then return to us. Distance punishes the signal twice. A world many times larger than Earth can still be too faint for a casual survey. Its apparent movement is also slow. Nearby asteroids slide between stars within hours. Planet 9 may move so little that images from the same night look identical. The useful comparison may be months or years apart. Much of the remaining search region lies near the crowded Milky Way. A faint moving point can disappear among millions of brighter, fixed points. So astronomers repeat one patient test. Photograph a field, return later, align the stars, subtract one image from the other, inspect every dot that refuses to stay still. Surveys using the Zwicky Transient Facility, Dark Energy Survey, and Pan-STARRS have ruled out about 78% of one leading Planet 9 parameter space, That does not mean 78% of the outer solar system has been searched. It means most places predicted by that model were tested deeply enough to exclude the planet. What remains is harder. Fainter territory, crowded sky, and orbits that shift as evidence changes. The planet has not simply dodged a telescope. The search box itself keeps moving. Astronomers do not discover distant objects evenly across the sky. Telescopes choose certain places and times, under different weather and limits. A catalogue pattern can partly reflect where we looked. Some carefully bias-modeled surveys found no convincing clustering. Supporters argue that other orbital features still need explaining. Both sides agree the distant objects are strange. They disagree about what made them strange. Then came 2023 KQ-14, nicknamed Ammonite. Subaru found it beyond Neptune. 19 years of observations revealed a stable orbit reaching deep into the outer solar system. Ammonite is only the fourth known Sedna-like object. Its orbit appears stable since the solar system was young, making it less a loose stone than a fossil of the early system. Its path does not align with the other Sedna-like objects, weakening the simplest clustering argument. If Planet 9 exists, Ammonite may push its allowed orbit farther away and make it even harder to find. The newest clue did not close the case. It made the suspect more elusive. A passing star in the young solar system could have lifted objects into detached orbits. A planet may have shaped them before being ejected, or the pattern may shrink as more objects are found. Planet 9 has not been found. Its evidence is real but disputed, and no single observation demands that a planet must be there. That is the honest answer. That is why the next search matters. A useful hypothesis predicts what should be seen, where to look, and what would prove it wrong. Planet 9 has reached that stage. The Vera C. Rubin Observatory has begun the most powerful repeated survey of the southern sky ever attempted. Its camera records enormous fields, then returns again and again. Rubin is built to find change. Asteroids, comets, and distant icy bodies reveal themselves by moving. Planet 9 could use the same disguise, but cannot remain still forever. If it appears, the first image will look like a faint point shifted between exposures, not a new world. Repeated observations must show that the point belongs to the Sun. Follow-up telescopes could measure its orbit and brightness. Larger instruments might resolve a tiny disk. Its atmosphere, moons, and history would come later. Discovery begins with movement, not a portrait. Finding it would add a new giant planet and force us to explain its remote orbit. It may have formed near the known giants and been thrown outward, or been captured while the Sun was young. Not finding it would matter just as much. The allowed region would contract, and the orbital pattern would need another cause. The solar system's violent early history would become the main suspect. Either result changes the map. This is not a choice between a planet and nothing, but between a world hiding in the dark and evidence our solar system once lost one. We call this our cosmic neighborhood. Yet somewhere beyond Neptune, the difference between 8 planets and 9 may still be only a few pixels moving across a field of stars. The lens does not blink. Subscribe, because next time we point farther still, at the Oort cloud, a vast shell no telescope has seen, revealed only by visitors falling from it.